On thin ice, a look at polar wildlife in a changing world. From the frozen expanses of the Arctic to the icy plains of Antarctica, the polar regions stand as a testament to nature's resilience.
A fragile web, loss of biodiversity. The intricate tapestry of life in the polar regions is woven from a rich diversity of species, each uniquely adapted to survive in these extreme environments. Yet, climate change is pulling at the threads of this delicate web, threatening to unravel the interconnectedness that holds these ecosystems together. As temperatures rise and ice melts, the very habitats that polar species rely upon are disappearing. The loss of sea ice, for instance, has a devastating ripple effect throughout the entire food web. Consider the plight of the iconic polar bear. These majestic creatures depend on sea ice as a platform for hunting seals, their primary source of food. As the ice recedes, polar bears are forced to travel farther and expend more energy in their search for prey.
Invisible threats, increased disease risk. The pristine landscapes of the polar regions might seem untouched by the diseases that plague other parts of the world. However, climate change is creating conditions that are increasing the risk of disease outbreaks among polar wildlife. Warmer temperatures, for instance, can create more favourable conditions for pathogens, including bacteria and viruses, to thrive. These pathogens can infect wildlife through contaminated water, soil, or direct contact with infected animals. Furthermore, the stress that polar animals experience due to habitat loss, food scarcity, and other climate-related pressures can weaken their immune systems, making them more susceptible to infections.
The sea turns sour ocean acidification. The vast expanse of the ocean might seem unchanging, a constant in a world in flux. Yet, beneath the surface, a silent transformation is taking place, driven by the invisible hand of climate change, ocean acidification. As the concentration of carbon dioxide in the atmosphere increases, a significant portion of this excess CO2 is absorbed by the ocean. When carbon dioxide dissolves in water, it forms carbonic acid, the same weak acid found in carbonated drinks. This process, known as ocean acidification, is lowering the pH of seawater, making it more acidic. This might seem like a subtle change, but it has profound implications for marine life, particularly for organisms that build shells or skeletons from calcium carbonate, such as corals, mollusks, and certain types of plankton.
Chapter 4. The Fight for Resources, Increased Competition and Predation. In the unforgiving landscapes of the polar regions, survival hinges on access to essential resources: food, shelter, and breeding grounds. These regions are home to a variety of species, each uniquely adapted to the extreme cold and scarcity of resources. Climate change is intensifying competition for these limited resources, pitting species against each other in a struggle for survival. As temperatures rise and ice melts, the delicate balance of these ecosystems is disrupted, leading to fierce battles for food and territory. As melting ice opens up new areas of open water, it creates opportunities for some species while putting others at a disadvantage. The changing landscape forces animals to adapt quickly or face the threat of extinction. For instance, certain whale species that thrive in open ocean environments are venturing further poleward, following their prey as it shifts its distribution in response to warming waters. These whales are now competing with native species for the same food sources, adding another layer of complexity to the ecosystem. However, this movement of species into new territories can lead to increased competition with native species that are already struggling to adapt to the changing conditions. The introduction of new competitors can disrupt established hierarchies and force native species to alter their behaviors and strategies for survival. For example, the Arctic fox, a master of survival in the harsh Arctic tundra, is facing increasing competition from the red fox, a more adaptable species that is expanding its range northward as temperatures rise. The red fox's presence in the Arctic is a direct result of climate change, and its ability to outcompete the Arctic fox for food and territory poses a significant threat to the latter's survival. This shift in species dynamics highlights the broader impacts of climate change on the intricate web of life in the polar regions. Across the vast expanse of our planet, countless species undertake extraordinary migrations, journeys that span continents and oceans, guided by the rhythms of nature. Yet, climate change is disrupting these ancient patterns, throwing these finely tuned migrations into disarray. For many polar species, migration is not a choice but a necessity. They depend on the seasonal formation and retreat of sea ice to access breeding and feeding grounds that are critical to their survival. However, as sea ice forms later in the year and melts earlier, it compresses the time window that animals have to complete their migrations and reproduce. This can lead to mismatches in timing, with animals arriving at their breeding grounds too late or finding that their food sources are no longer available.
In the harsh and unforgiving environments of the polar regions, where temperatures plummet to extreme lows, life is a constant struggle for survival. The icy tundra, with its relentless winds and freezing conditions, presents a formidable challenge to all forms of life that inhabit these areas. As the sunlight fades and the long polar night sets in, lasting for months on end, the scarcity of light further complicates the search for food. In these conditions, access to a reliable food source can mean the difference between life and death for the wildlife that call these regions home. Yet climate change is disrupting the delicate balance of these ecosystems. The melting ice sheets and rising temperatures are altering the availability of food sources that polar wildlife depend upon for their survival. Adelie penguins, for instance, are finding it increasingly difficult to locate the fish and krill they need to sustain themselves. At the heart of this disruption lies the impact of warming waters on the distribution and abundance of plankton. These microscopic organisms form the base of the marine food web, serving as the primary food source for many marine species. These tiny plants and animals drift with the currents, providing sustenance for a vast array of creatures, from krill to whales. The health and abundance of plankton populations are crucial for the survival of these larger marine animals. As ocean temperatures rise, the distribution of plankton species is shifting. Warmer waters are causing some species to move towards the poles in search of cooler environments, while others are struggling to survive as their habitats become increasingly inhospitable. Some marine species are migrating poleward, seeking the cooler waters that are more conducive to their survival. This migration is not without its challenges, as these species must adapt to new environments and compete with existing wildlife for resources. Meanwhile, other plankton species are experiencing significant declines in their populations as the warmer temperatures exceed their tolerance levels. This decline in plankton has a ripple effect throughout the marine ecosystem, impacting all species that rely on them for food. These shifts in plankton communities have cascading effects throughout the entire food web. The decline in plankton populations affects the availability of food for krill, which in turn impacts the species that feed on krill, such as fish, seals, and whales. The entire marine ecosystem is interconnected, and changes at the base of the food web can have far-reaching consequences for all species within it.
Imagine a world where the very ground beneath your feet is disappearing, where the stability of the land is no longer guaranteed. This is not a distant future scenario, but a present-day reality for many regions around the globe. The once familiar landscape is transforming before your eyes, reshaping ecosystems and altering the very fabric of life that has existed for millennia. The polar regions, in particular, are undergoing dramatic changes. This is the reality facing many polar species as climate change melts the ice that has shaped their world for millennia. The ice, which has been a constant for these species, is now retreating at an alarming rate. The most immediate and visible impact of climate change in the polar regions is the loss of sea ice. This ice is not just a frozen expanse, it is a crucial component of the polar ecosystem. This frozen platform is not just a vast expanse of white, it's a dynamic ecosystem that supports a rich diversity of life. From microscopic algae to large mammals, the sea ice is a lifeline for many species. For polar bears, sea ice is their hunting ground. It is where they find their primary prey, seals, and it is essential for their survival. They rely on it to stalk seals, their primary prey, waiting patiently near breathing holes or ambushing them on the ice edge. Without this ice, their hunting strategies are rendered ineffective. As sea ice diminishes, polar bears are forced to spend more time on land, where they are less efficient hunters and have to compete with other predators for scarce food resources. This shift not only affects their physical health, but also their reproductive success. The loss of sea ice also has devastating consequences for ice-dependent seals, which rely on it for giving birth, raising their pups, and molting. These seals are adapted to a life on the ice, and without it, their survival is in jeopardy. The cascading effects of habitat loss in the polar regions are profound, impacting not just individual species, but the entire ecosystem.
The polar regions, once thought to be remote and unchanging, are now on the front lines of climate change, bearing witness to the profound and far-reaching impacts of our actions. From the loss of biodiversity to the disruption of ancient migration patterns, the delicate balance of these ecosystems is being tested as never before. Yet amidst these challenges, there is hope.